Piecewise functions are simply just functions that are made up of a lot of little pieces. So here I just said it's defined by multiple subfunctions, but just think it's exactly what it says it is. It has pieces that make up the big function. So let me give you an example. This is fines for speeding, and I have Orange County because I couldn't find Hillsborough County online. And it just shows you that depending on how fast you are going, there's a different amount that you're going to pay for speeding. And I thought, well, could we write this as a math equation? So here you can see that I did. And what I look at is X is how fast you are going, like over the speed limit, and then the output is how much would we pay. So you can see that this 129, I wrote right here, is when your speed is between, let's say 5 and 10 miles over the speed limit. So not under, let's say not 5. I didn't include 5, so I'm saying over 5, but still less than 10. So somewhere between those two values, that would be the 129 fee. But say you did go between 10 and up to 15 miles an hour over the speed limit, which is what I show over here, then you're going to pay $204. If you go 15 all the way up to 20, so that's what I put over here, there's a $254 charge. From 20 to 30, then you pay $279, and then over that, you're going to court. So they don't even quantify that with a number. All right. Some other examples to show you other places this could occur. So I just went on the internet and I found this called the Cup Store. And you can see they have a different kinds of cups, so different sizes, 8 to 20 ounces, and then they start changing the price of how much they charge you per cup based on how many cups you buy. So different discounts at different quantities. Let's make it easier and just pick one particular cup. So I picked the first line, which is 8-ounce double-walled paper cups. And it shows you the prices based on how many you're purchasing. So I said, well, let's look at a couple purchasing points we might want to make. So I picked $250, $300, $750, $1,000, and $1,200. And then let's figure out how much it would cost. I'm going to call it C for cost. And an X will be like the number I put in will just be how many cups we're buying. So let's start with 250. So the 250, it's between 120 and 300, so I'm still in the 120 price. So it's 91 cents a piece. So I take 91 cents, I multiply it by 250. It says we'll pay $227.5 for these cups. Let's raise it to 300. So 300 pushes us to a different price category. So now we're paying 74 cents a piece. So this 74 cents a piece times 300 cups says I'm going to pay $222. It's kind of awesome news. If you're buying 300 cups, you're actually saving money, like $5.50, by buying 50 more cups. So that's something you would definitely want to look at if you were purchasing large amounts of things, is look at the discount we get for ordering more. 750 goes into the 600 plus category. I have 69 cents times 750, which is 517.5. And then 1,000 still is in that same category. So just it depends on what number I pick, but I pay attention to what category does it fall into. So 1,000 times 0.69 is 690. Then the last one I had was, what if we buy 1,200? So 1,200 is right here. That's 45 cents a piece. So 45 times 1,200 is $540. That should be shocking to you. Look at this, 1,000 cups was $690, but I could buy 200 more and save $150, which is just like a wow to me. I would definitely be buying those $200 more to save some money. So it shows you the complexity of this in the real world. This is definitely from the real world. I just pulled it right from the internet to show you here's how piecewise works. Other places that are really typical, when you go to the movies, you probably never thought about it, that this is a piecewise function. So I thought, let's write it as a function. So what my variable is really that I'm inputting, so my first thing I'm starting with is, this is based on age, right? Depending on how old you are is how much you pay. So when I'm setting up this function, I'm letting X represent the age of the purchaser or who the ticket is for. Notice the starting age is 2, so I included over here that there's no cost if someone was less than 2. But from 2 to 12, which is what they have under the where it says child, the price was $8.19. So you're supposed to assume from that once someone's over 12, I guess they're an adult, and that goes until 60 where they become a senior citizen. So from 12 to 60, it was $11.19, and then 60 and above, it was $9.69. All right, here's another thing. This one's kind of misleading, but we'll go with it. So it shows you different prices that you're going to pay for a monthly membership into this club. And you pay based on how many months that you borrow, or not that you borrow, but that you're a member. So X is going to be the number of months that we borrow. But here's what's interesting, I think, is see how I didn't put this condition? Because this doesn't say from 1 to 3 months. It says 3 months. So when X is 3, you're going to pay 7.95 times X. So if you're only in there for 1 month, that's not a choice. You're in there for 3 months. So 1 month, 2 month, whatever, you're paid for 3. 6 months, you pay $5.95, and 12 months, you pay $4.95. What happens is you do pay every month. So month 1, you pay $7.95. Month 2, you pay $7.95. Month 3, you pay $7.95, and that would be your total. But this one is a little different, but just I wanted to show you a membership idea. If this one confuses you, just go ahead and keep watching. We'll click on to the next one. I'm going to reverse the idea, and instead of showing you the output, I'm going to, like as numbers, I'm going to show it to you as a graph. So here's the first graph, and I tried to keep it really simple to start, and we just, again, want to find a function that models it. This one's nice because there's only 2 outcomes. It can either be 1 or it can be 3. That's it. The 1 happens when I have a negative number. The 3 happens when I have a positive number. And it also happens when it's 0. So I said, here are my outcomes. I get 3 anytime X is greater than or equal to 0. I got 1 anytime it was less than 0. So very straightforward one there. I'm changing this one up a little. I added a third piece to it. And let's do the easy pieces first. And these are the easy pieces. They're just the horizontal lines. So this top one is 4. And when does that happen? Anytime X is bigger than 3. The smaller one is -2, and that happens anywhere from -1 all the way up to and including 3. So notice I'm looking at what outcome did I get? That's my Y, but the input is my X. So this other one that's a little trickier, I wanted to say, let's pay attention to these points and say, do we see anything? So I see that -5 gives me 5, -1 gives me 1, and those two numbers are almost the same. Right? The difference is a sign. So what I have is whatever I put in, I just make it the opposite. So I'm thinking of that as -x, and that happens from -5 up to -1. So let's grab those 3 things and put them back together. So this part was make it the opposite. There's my negative. So -x from -5 up to -1. And then once I got to -1, I get a -2, so -2 from -1 over to 3. And then once we get to 3, as my x, it's going to give me 4, and that's just going to finish off the function. Okay, this one. Again, 3 segments, but maybe you don't see 3 at first. All right, so here's the first part. -2 gives me 2. So when x is -2, the answer is 2. That one's pretty good. The second part, let's just pull this part that's touching the y-axis first, because that will be a little hint for us. So I have an intercept at -3. That's going to be important because I'm going to need that as part of finding the equation of this line. So if I know the intercept, the other thing I would need to know is the slope. And I can get the slope because I know 2 points. I know this point. I know this point is -2, -1. I know this point is 0, -3. So what we need to do is find the slope of the line containing these 2 points. So remember how you do y2 minus y1 over x2 minus x1? That's what I did here. I did -3 minus -1. I did 0 minus -2. Remember, negative becomes positive, so this is really -3 plus 1, which is -2. This is 0 minus -2, which is really just 0 plus 2, so that's 2. -2 over 2 gives me -1. So I have a slope of -1. I have an intercept at -3, which says I have a line at -x minus 3. as soon as x is greater than negative 2. All right, on the other side, I also have a line. This one should have a positive slope. And once again, I can see 2 points. I have negative 4, negative 2. I also, again, am using this negative 2, negative 1 point. Let's start with the slope this time. So again, change in y, change in x. So I have negative 1 minus negative 2. That's going to be 1. And then I have negative 2 minus negative 4. That becomes 2. So here I'm doing my negative. Negative is positive. This is negative 1 plus 2. Negative 2 plus 4. So I have 1/2. All right, there's my slope. This time I don't have the y-intercept, so I don't have that extra little help to finish off. So I'm going to have to put this in point slope form. So I'm going to do y minus, and I used the first point here. So I did y minus negative 2 equals, here's my slope that we just found, and x minus negative 4. Okay, again, make these positive, make this positive. So I have y plus 2 is 1/2 of x plus 4. I want to distribute the half. So here's 1/2 of x, here's 1/2 of 4 is 2. This 2 cancels this 2, so I have y as 1/2 of x. All right, and if you pay attention, this happens for any number less than negative 2, so that'll be my condition. Okay. So here I just kind of put it back together. I hope you can see it okay. This is 1/2 of x when it was less than negative 2, so that was this part. Then it was just 2 when x was negative 2, and then on the right side, everything else was negative x minus